Hello, this is video 5-6 part D. 4 videos? Are you serious, Schwarberg? Yeah, I'm sorry. And I know they're long. Fundamental theory of calculus. It's kind of fundamental, though. It's very, very complex. Actually, well, simplistic, but I say that. Fundamental, you need it. And what we're going to do is go ahead and look at one other topic in integration called start plus accumulation. And we're going to see how we can apply this to kind of help simplify integration, okay? So we'll start off with the fundamental theorem of calculus, which says the integral from a to b of a derivative is equal to f of b minus f of a. And those are the problems that we kind of just did. But what if I already have one of these outputs? Okay, what if I already have a point? Well, I can start out with that value, okay, and then I can add on the rest of the integration. So in order to find a certain value here, f of b, okay, I can take the integral of the function's derivative from a to b dx and then add the f of a. So I'm going to start out with the value and then I'll add the accumulation, right? So that's why it's called the start plus accumulation, because I have this value that I start with plus I am accumulating. Okay, so that's start plus accumulation method. Okay, so let's go ahead and look at some examples here. So we have if f prime of x is equal to 3x squared plus 3 and f of 0 is equal to 4, find f of 2 without a calculator. And maybe you're thinking, hey, like this is an initial value problem. And I mean, that's kind of right? So it's the same way, except it's slightly different. And I'll show you. It'll make more sense on 14. This one kind of looks just like a initial value problem. So I have f of 2. I want f of 2. Well, f of 2 is equal to f of 0. They give us f of 0 plus the integral from 0 to 2 of f prime of x. Okay, and in this case, it is 3x squared plus 3. Okay, so, and this is dx. So we'll go ahead, I'm going to replace f of 0. I know f of 0 is 4, okay, and then I want the rest. I want the rest of this function 2, to find 2. So I'm going to go ahead and integrate. So I have 3x cubed divided by 3 plus 3x, okay, and there I have it. So I'll clean this up. Okay, and we get 4 plus, sorry, and I need to evaluate this from 0 to 2. So we have x cubed plus 3x. Okay, so if I plug in 0, all of this is going to go to 0, so I can just evaluate this at 2. So I have 4 plus 2 cubed plus 3 times 2, which is 6, and this is 18. Okay, so there's the start plus accumulation method. Let's go ahead and look at this example 14. It says if an object's velocity v of t is equal to 2 to the power of t and s of 2 equals 8, find s of 3. So I know this is a start plus accumulation problem because they give us a starting point, s of 2 equals 8, and then they want me to accumulate. They want me to go from 2 to 3. Okay, so if I want to find s of 3, I know I have to start out with a value, so that's s of 2, okay, and I have to accumulate. Well, how do I accumulate? You're going to integrate from your initial value, so 2, all the way to 3, okay, and I'm integrating the derivative v of t, okay, so that would be v of t, okay, so that's 2 to the power of t dt, all right, and I'm going to go ahead and now replace. So I know s of 2 is equal to 8 plus, okay, and I have this value here. So note for our class, we have not integrated an exponential yet being the key word. So from 2 to 3, 2 to the power of t dt. So what we're going to do is we're going to go ahead and we're going to use our calculator. So hopefully you can kind of see this. And I'll place this right over here. Okay, so I'm gonna go ahead and integrate this. So menu, calculus. I want a numerical integral. Okay, and I'm going from 2 to 3 of 2 to the power of t dt, and I want to add 8. So I'm just going to add on 8 here. Okay, and we get our answer, which is 13.771. Okay, so this is equal to 13.771. And there it is. Okay, that is start plus accumulation method. All right, catch you next time. Peace.